the 6A review, and I've actually gone over every single question in my other classes. So it's all filled out and done, but I want y'all to have a chance to ask your specific questions as well. And I'll go so the words are going to be written on there, but I'll walk you through it and explain the process.
Like the first part, like the first full part.
Like that, like 1 through whatever?
Yeah.
Okay. All right, so let me pull that up. Okay, so in this first section, 1 through 6, this is matching. You're matching the visual of the transformation happening. This is the composite transformations where you do 2 things in a row. And you're matching it to which of these A through F it shows. Okay, so actually I've already done it here, but like for number 1, for instance, okay, when your arrow does not change orientation, so it's still pointing directly to the right, it's a horizontal arrow pointing to the right, we just slide it. Okay, from step 1 to step 2, it was just a slide, which is a translation. Okay, when you translate something, the orientation is not affected. Okay, but then you can see from the second to third piece, the orientation changed. It went from pointing right to pointing up. That's not a reflection. A reflection would be, it would either point to the left if it was reflected over the vertical axis, or it would still be pointing right. It would just be lower if it was reflected down, for instance. Okay, so this is a rotation. It is turned. Okay, so this is a slide followed by a turn. That's a translation followed by a rotation. So that's why it's B. Does that make sense?
Yeah.
Okay, so that's what I went through on each of these and did. And if you need me to, you want to watch it in, without all the writing there already, I'm going to post the videos. I would go back and watch that video so you can see I did that for each one. Okay, but you're just identifying what type of transformation took place between the first and second image, and then what between the second and third image. So you're finding the correct order of the transformation because the order matters. What else?
Number 27.
27. Okay, so on 27, I think this is the one where you reflect a line. Yes. So I showed this graphically to, and if you want to see it cleared out and done, this is in, I think I did it in 3rd period. You'll be able to watch that in that video if you needed to. Okay, but you can see I graphed the original line here. The solid line is the original linear function y equals -4x plus 3. You need to remember that a line in this format, the m is the slope and the y is the, the b is the y-intercept. So I started at 3 on the y-axis, and then I counted a slope of -4. So you can go down 4, right 1, or you could have gone up 4, left 1. But that's a -4 slope for the solid black line, and it crosses the y-axis at 3. Everybody good with the original graph? Then they ask you to reflect it using this rule. This rule where x changes sign and y does not, that means it's being reflected over the y-axis. Okay, and remember, you're going to be given those rotation and reflection rules on your scratch paper / formula chart. Okay, so you'd be able to look and see, oh, that rule is reflecting over the y. So I kind of put a red line here over the y-axis because that's what I want to reflect across. So graphically, I would take each of my points, the 2 or 3 points that you plot to draw your original line, and reflect them. Now, the y-intercept is on the y-axis, so it doesn't go anywhere in a reflection over the y-axis. But this point moved to the left, from the right to the left. This point moved from the left to the right. So this dotted line is the reflection. Does that make sense? Now we had to write the equation for that. You can see, well, the y-intercept did not change. It's still at +3. That's my b value. And then the slope, if I were to count that, is now up 4, right 1. That's a +4. So we have a +4 slope and a +3 y-intercept. So this is the equation of the new line. And I want you to see from the original to this new one, what's the only thing that changed? Yeah, I highlighted that in yellow. The -4 became +4. Because notice in the rule, the only thing that was changing was the X sign. So we changed the sign in front of X. If we put a -X here, what's a -4 times a -X? Well, it's a +4X. So that was the only change. Had this been a reflection over the X-axis, for instance, if I had this original line and I wanted to flip it over the X, wouldn't that y-intercept change to be -3? If I reflected that point down below the X-axis? Can y'all visualize that?
Yep.
So if you're reflecting over the Y-axis, your y-intercept doesn't change. But if you're reflecting over the X-axis, the y-intercept would have also changed signs. Okay, so in this case, only the slope changed sign. If it was reflected over the X-axis, both the slope and the y-intercept would have changed signs. Okay, so if you understand that, you don't have to graph it every time. But if you don't, you can always do it by graphing and actually doing the reflection of the points. What else?
Can you do 11?
11. All right, so on these, you're looking for how many lines of symmetry that have reflectional, so all of these had reflectional symmetry. You want to know how many different lines it could be folded over and be symmetrical. Okay, so in this case, this was a 7-pointed star. Okay, and so there were 7 lines of symmetry. And that also meant, because this was the same all the way around, it was regular, if you will, the order of rotational symmetry was 7. But remember, to get the degrees, you do 360 divided by the order. Remember, the order is how many times you could rotate this in a 360-degree rotation, and it would line up on itself. So I could rotate this 7 times, or I could rotate it 360 degrees, and 7 times throughout that rotation, it would line up right on top of the original. Okay, so 360 divided by 7, you do get a decimal. It did not tell you what to round to, so I just went to hundredths. If you went to tenths, no biggie. If there's one that's a decimal on the test, it will specify what to round to. Charlotte?
Can you just explain how to do like 16, like or 21, like how do you do it?
Yeah, on 16 through 21, this is the, oops, I did not mean to click that. On 16 through 21, this was just a matching, essentially. Okay, you're just saying, this is the rule. Is it a reflection or a rotation, and which type of, like what size rotation or what type of reflection? What's the line of symmetry? So remember, on the back of your review, you have the scratch paper that had all the grids, and it had these rules. These are the rules that are here in these problems, 16 through 21. So these are the rules. It's really just a matching question, and you select it. You didn't even have to have them memorized, because these are the ones you're going to be given on the test as well. Okay, so you're going to be given your reflection rules and your rotation rules. These rotations are counterclockwise. Unless it says otherwise, your rotations are always counterclockwise. Gunnar? And then Julia, which ones did you like? Okay. All right, let me do that one real quick, and then I'll go to the back page. Okay, on 15, this was similar to what we were doing on that activity with the straws last week, where you cut out the shapes, the 2-dimensional shapes on paper, and taped them to the straw and watched the rotation. to try to visualize that 360-degree rotation, the solid or 3D shape that would be created. Okay, so on this, you said the second one? So the second one is like half a heart, if you think about it two-dimensionally. If I were to reflect that, yeah, that would just be a heart shape. But rotating it 360 degrees around this axis, it creates a solid, okay, and it's curved because you can see this side is curved. So, but it's narrower at the top, it gets wider as it comes up, and then it dips in the middle. Okay, so you could have called that like a 3D heart. I saw some people call it, that's fine. Or in that activity we did, we said it made an apple shape. So you could just say apple if you wanted to, that's fine too. Yeah.
So like a ball.
Yes, that's fine. So the last one, I do want to clarify, even though that's not shaded in the middle, like if you were to rotate this 360 degrees around, it is solid. That hole in the middle does not, you can't see it once it's a solid. It's a hollow or empty sphere, or what did you call it, Maxim? A ball, or maybe like a bubble, however you want to think of that, but it's a sphere that's empty on the inside. It is not a hole that you can see through. It's not a donut shape or a tunnel that's created, because when that circle goes, when that semicircle, I should say, rotates 360, it encloses the outside completely. So yeah, it would be good to think of it as a ball with like a really thick skin, and then the inside's just air, empty. Does that help? Okay, so then we're going to flip to the last page. You said 29 and 30. Okay, so on number 29, this one actually kind of goes hand in hand with those first 6 that we looked at, where you're having to do the composite. On the first 6, we were looking at a visual of the composite transformations. Here, we don't have a visual. We're just given 3 points, and we're told, hey, it's translated using this rule and then reflected over the x. Well, this rule, x minus 3, that means left 3. So we're translating it left 3, and then we're reflecting that over the x-axis. So that's what I did here. Here's the original LMN. Here's after the translate left 3, and then here's after the reflect over the x. So these are the points that it ends up at. Now a student claims, okay, if I flip it and I do the reflecting first and then the translating, it's going to be identical. It's going to have the same result. So I tried it. I took my original 3 points and I reflected them first, which changed the sign of y, and then I translated them. And what do you notice? Did they come out the same? Yeah, so the student was correct, but the why is very important here. Okay, if you just say yes or no and you don't understand why, that's no good. In this particular instance, the student was correct. This does not always work. You can't just switch the order and it always comes out the same. The reason this is a special case, because normally order matters, okay? That's what we learned on the front looking at those images. It matters if you translate or rotate or reflect and then do something else, right? But here, this is a special case because the translation is parallel to the line of reflection. The line of symmetry that we reflect across is the x-axis, and our translation is affecting the x. It goes along the x-axis. So because I'm translating along parallel to the line of symmetry, that's the reason that they came out the same. So had this been a vertical translation, up or down, and then reflected over the x, they would not have come out the same. Does that make sense? Do you understand what I'm saying? Okay. So it's really important that you understand that the order does matter. That's called the commutative property. For most of y'all would know it for addition. At like, let's say 2 plus 3, That's the same as 3 plus 2, isn't it? Because addition is commutative. The order doesn't matter. Transformations are not commutative. The order does matter. This is a special case just because the translation is parallel to the line of symmetry. That's the only reason that this comes out the same. Normally it would not, if it would, because transformations are not commutative. And he said 30. Okay, so 30 was asking, okay, given this QRS that we start with, we're told we translate it, and this is the rule. This rule means up to. With the y, we're adding 2 to y, that's up to. So we shift it up to and then reflect over the x. What is the single transformation that would produce that same result? So I did the transformations. I did in red the translate, and then in blue the reflect. So here's my original in black, my pre-image, and my final image, the double prime QRS, in blue. So I look at those and I ask myself, okay, how could I get from Q to Q double prime? Well, the X stayed the same. The Y, I could subtract 4, right? And that would be a single transformation to get from here to here. But then when I check to see that's the same for R, if I did subtract 4 from the Y, does that get me 0? No. So that doesn't work. Okay, and then I look again. I'm like, okay, what else? What else? It's not just a simple sign change. So it's not switching the X or Y. So it's not a rotation or a reflection. What about a dilation? If I multiply 1 times -3, that would get me -3, right? But if I multiply -2 times -3, does that get me 0? No, so that doesn't work either. So there is not a single transformation that would give you this same result in one fell swoop. Okay, it has to be a composite. Does that make sense? Okay. Can y'all think of one composite that would have a single transformation that could get you the same thing? Does that exist? Let's think about reflect. What if I had a point and I reflected it over the X and then reflected it over the Y? Remember, reflecting over the X, if we go back and look at the rules, remember these are the rules that you're going to be given. If I reflect over the X, see how the Y changes sign? And then I reflect over the X changes sign. So if I did both reflections, I did a composite and I said reflect over the X and the Y, wouldn't both signs end up changing? Now look at your rotations. Is there a rotation rule where just both X and Y change signs?
180.
Yeah. So rotating 180 results in the same image as reflecting over the X and the Y. So there are some instances where you could have a composite, okay, two different, like a combination of two transformations, and you could find a singular transformation that would result in the same thing. So it is possible, but in this case that there was not one. Say again? 28? Yeah. So I'm just going to scroll up here. So on 28, again, we're given 3 vertices. This is the one that had the typo that was supposed to be X, Y, Z. Not that it really mattered. But you have these 3 vertices of your triangle, and they say they're translated and then reflected. And you can see the translation is to the right 3 and down 2. And then it's reflected across the line y equals -x. Now, if you wanted to graph this and see a visual, you could do that. If you are a visual person and you need to see that triangle, graph it. Perform the transformations and graph the new image and look at them. Okay, but you don't have to actually have the image to understand this. if you get the concepts. So the concept of rigid transformation, that's translate, rotate, and reflect. Those are the three we focused on the most here in this unit. Translations, rotations, and reflections are rigid transformations. What does rigid mean? If something is rigid, it is like firm or stiff, right? It's unchanging. So when we translate, rotate, and reflect, our image stays firm. It does not change size. It maintains its congruence. So you can translate and rotate and reflect, and it is still congruent to the original image. Does that make sense? It's still the same size and same shape. It's just drawn in a different location or maybe at a different angle. Does that make sense? Okay, so it does maintain its congruence, so it does not get larger or smaller. Getting larger or smaller, that's a dilation. Dilation's the only one. Yeah, dilation's the only one that's a non-rigid transformation. It changes the size. It's no longer congruent. It's proportional, but not congruent. Okay. And then the orientation, some people were confused when it said the image is oriented the same or differently when you're trying to decide between those. The orientation is like the direction that it, or the angle that it's drawn at. So if I have, I did this in my other videos with like the letters. I'm going to use a triangle this time. Okay, so if I have a triangle, if I have this triangle, if I translate means slide, right? So if I slide this around, am I changing the direction that it's drawn at? No, the right angle is still in the bottom left. The hypotenuse is still on the right. Do y'all understand what I mean when I say it, the orientation's not changing as I slide it all over this page, is it?
Yeah.
Okay. However, if I reflect it, if I were to flip this, and it doesn't matter if it's flipping it up, down, left, right, over the line y equals x or negative x. Now that I've flipped it, it's a different orientation. Now that right angle is in the bottom right instead of the bottom left. Y'all see that? So that's what we mean when we say the orientation changes. So it's going to have a different orientation if you make a reflection, or if you make a rotation. If I rotate something, the orientation changes, right? So reflection, translating does not change the orientation, but reflecting and rotating do. Okay. So I don't know if seeing that triangle move around helped you or not, but so if you have a translation, then a reflection, it stays congruent, but the orientation is different because of the reflection. Not because of the translation. If it was just a translation, it would have been oriented the same. I mean, at the same angle or degree. What else?
Wait, can you go over like, or I just want to make sure mine's like 22 through 26.
Well, I'm gonna post the key later, so you can check them later if you're just wanting to check. Is there anything else you didn't understand, like the process or the reasoning? If you want to just check answers, I'm gonna post the key, and I'm gonna post all these videos, and you'll be able to just check the answers later. But if you need help with the actual process of something or understanding the concept,
I need help on the one of the lessons on the extra credit because it's due tomorrow.
Yep.
Okay.
Okay. Yeah, we can pull that up. So I'm gonna pull up the extra credits.
My only thing I had trouble with was the composition.
The Delta Math is the 5-point extra credit. We did a worksheet this week and then a Canvas assignment. Okay, let me go to the extra credit in Delta Math. Right here at the top of the unit. Which type of question was it, Sophia?
Composition of transformation.
Okay, So in this type of question, composition of transfer, this is like the double, like is it just the way that it's written that's confusing you or the actual process?
It's the way that's written. I don't.
Okay. So just like on our formula chart that I said you're gonna get, if you look here, like they just put a R for reflection or rotation, and then they put like as a subscript what the line of symmetry or the degree of the rotation was. That's the same concept that they're using here, except they're using a capital R for rotate and a lowercase r for reflect so that they're different. So this is saying, what is this point going to become after I rotate it 180 degrees, and it doesn't say which direction, so what is it? But what counterclockwise or clockwise, if it doesn't say? Counterclockwise. Counterclockwise unless it tells you otherwise. And those rules that you're going to have on the test are the counterclockwise rules. So just use those rules for rotations. Okay, so it says go rotate 180. And 180 actually doesn't matter if it's clockwise or counterclockwise. But so 180 degree rotation. That rule says to change the sign of both X and Y. Okay, so this is not my final answer. This is just momentary. So that would become 6-1, right? Okay, so after the rotation, we're at 6-1. Now we want to reflect over the line y equals negative x. Well, the rule for y equals negative x is that you switch the order of the x and y and the signs of the x and y. So I'm going to switch the order. So it's going to be 1 and then 6. And I'm going to switch the sign. So they're going to become negative again. Does that make sense?
Yes.
So that's what you're doing on this section. Okay. But yeah, it'd be like they use a T for translate and then it's X and then Y. So that means the X is not changing since it's a 0 and you're a positive 4 to the Y. So you're adding 4 to the Y. So X does not change, stays -9. The Y, you add 4, so it becomes -2. And then you rotate 90 degrees. Again, it doesn't say direction, so it's counterclockwise. Remember, rotating 90 degrees counterclockwise, you switch your X and Y, and you change the sign of the Y, right? So that would have become was the -2, was the Y, it's going to become +2. Oh, I messed up. Switch the X and the Y. Oh, I don't know why I put a 2 and not a 6. That was my bad. Wait. I have no idea what I did. Let's try a new one. I got my numbers mixed up. I was looking at a different number. Okay, so we have our point. Reflect over the y-axis means the y stays the same and the x changes sign. And rotating 180 means both the x and the y will change signs. So this is going to become +2 and -1. I'm going to find one with a translate. Here's another translate one. Translate, then rotate. So translate, subtract 4 from the x. So 1 minus 4 is -3. Add 3 to the y. So -2 plus 3 is +1. Then rotate 180. And again, that changes both signs. So that becomes +3 and -1. What in the world?
It's weird. I think.
Oh, it says start with the rightmost transformation.
Yeah, it's asking that, and let's be on the test.
Not in, it will be in words. It will not be it. So it's just, we did it in the wrong order than they wanted. So it's just their notation. They're wanting you to do the rightmost transformation first. So this is a good way to point out that the order does matter, because I translated then rotated, and that's wrong because they wanted us to rotate first then translate. But that's what I'm saying. It's the notation on this. We're not using that notation. That's just what Delta Math is using. So let's see if when you go to show an example, I guess every time it says start with the rightmost transformation. This one's a dilation. Start with the rightmost. So yeah. So when you're doing that section, you just have to understand you have to do the right one first. So, and let's try this one. So we have to do the translation first because it's the rightmost, and then the reflection. So if we translate, subtract 3 from the x, and then add 3 to the y. Then we reflect over the y. The y doesn't change, the x does. Yeah, that works. So you just have to do the rightmost first. That's it. So do the right rule first. And like I said, this is just a notation. Your test does not have this notation. Your test will be in words. It will say, you know, it'll say reflect and then rotate, or rotate, then it'll tell you what to do, what order. Okay. So just for this particular section in Delta Math, make sure you're following that rule of doing what's on the right side first. Was there another section of the extra credit or any other stuff that you had a question about?
No.
Okay.
Thank you.
No problem. Anybody else? Going once? Going twice?
Wait, we still can't, even if you want us to review the answers, you want us to wait.
On what?
Like the it's like 23 to 26.
Are you just wanting to check answers?
Yeah.
Yeah, no, I'm not doing that right now. Do you need help actually solving? Okay, then I'm going to stop this recording, and then I will be posting. So it's 3 videos, one for each class period, and I'll post the key after school.